So now what we're going to do is do some practice questions about potential and kinetic energy. And we're going to try to make these questions similar to the ones you might see on TCAP. So here's our first question. You can see here we have a model of a roller coaster. The ball is going to represent the carts on the roller coaster. And we've also got several points labeled throughout the roller coaster. At which point will the ball have the most potential energy? The correct answer is B. The ball will have the most potential energy at B because that's the highest hill. It takes more energy to get the ball up to point B than it does to get it to point F or any of the other spots. So the greatest amount of stored energy would be at the top of that tallest hill. Whenever you're faced with a question like this, look for the tallest hill because that's where the most work would have to be done to get to that spot. Now, here's the next question. Where would the ball have the greatest kinetic energy? Where would it have the most motion? The correct answer on this one is D. Right before it hits the bottom of the tallest hill is where it has the greatest motion, because by then it's received all the energy from this high point that was stored, and it's used up all of that energy, so it has a lot of motion. Some kids might think at just before G, because they think, oh, that's the end of the roller coaster, it has all that energy. But when it gets to the bottom of this hill, it spends a lot of the energy that it stored up from B to get to the top of the next hill. So G doesn't have as much energy. Now, look at this question. Here we have a bottle that was sitting on a desk, and it falls off, and it's almost hit the floor. At which spot would it have the greatest kinetic energy? 1, 2, 3, or 4? The correct answer is 4, just before it hits the floor, because it has a longer time to fall and receives all that stored energy from all these points combined here. Just before it hits the ground, it picks up the most speed. Now, in real life, you can make an argument that most situations there is both potential and kinetic energy. So what you'll need to do is listen closely to my description of what's going on in the picture so you'll know exactly which one I'm talking about, potential or kinetic. So in this one, we have a little girl who's poised at the edge of the pool. This is both potential and kinetic, but she's not fallen in yet. Is this potential or is it kinetic? Yes, it's potential. Now, is it because she's up high, or is it because she's being stretched or squeezed? Yes, she's up high, so she has the potential to fall because of gravity. Now look at this one. And again, it's both potential and kinetic, but listen to my description. The boy is doing a flip off the low dive. Is that potential or kinetic? Right, it's kinetic because he's in motion. Remember, if you see motion, that's kinetic. But because he's in the air, he also has potential energy. He could fall. Look at this kid. He's got this slingshot. It's pulled back, but he hasn't released it yet. Is this potential or kinetic? Yes, it's potential. Now, is it potential from the object's position or from its condition, its atoms? That's right, it's position. Now, is it position because the object's up high or because it's being stretched or squeezed? Yes, elasticity is being stretched beyond its normal position. That's what's giving it its potential energy. Now, here's a girl standing on the edge of the diving board. She's not moving. Is this potential or kinetic? Right, potential energy. Now, I don't want you to fall into the thinking that, oh, if something's moving, it's kinetic. That's true. And if it's not moving, it's potential. Not necessarily. In order for it to be potential, there has to be a reason. Why does she have potential energy? There's more than one answer to this. Yes, she has potential energy because of her position. She's up high. But even if she doesn't fall, Being up high gives her the potential to fall. Could she still move? Yes, she has potential energy because of her condition. The food she ate, the energy that was stored between those atoms, she now can use that to make her body move. She can just walk in the other direction if she wants to. Now, this is both, but listen to my description. The boys are sliding down the slide. Potential or kinetic? Right, it's kinetic because they're in motion. Kinetic energy is the energy of motion. They do still have potential energy, though, because they're not all the way to the bottom. They're up higher than they were originally, so they do have some stored energy. Now, look at this. This is a parked car on a flat driveway. Is this potential or kinetic? Right. Definitely not kinetic. It's not moving. It is potential. Is it potential because of its position or its condition? Well, if it's position, it's got to be either up high or stretched or squeezed. Is that what's going on here? No, so it's its condition. Where does the car get the energy to move? From the gasoline. Yes, the atoms in the gasoline, the energy holding those atoms together can be used to power the car. Let's try this one. Here's some gasoline. It's just sitting in the pump. It's not being pumped out yet. It's just sitting there. Is that potential or kinetic? If you said potential, you're right. Gasoline has potential energy because of its atoms. Now, here's somebody holding a car battery. They're just holding it. They're not moving it around. They're just holding it. Is it potential or kinetic? Well, it's not moving, so it's not kinetic, so it must be potential. Is it potential because of its position, being put up high or stretched or squeezed, or its condition, the atoms? Yes, both. It has potential to fall because it's being lifted up higher, but it also has energy stored inside in the acid. Those electrons will flow when it's connected to a circuit, so it's also condition. What is this one? Potential or kinetic? Yes, it's potential. She stretched this rubber band beyond its normal position. She used energy to do that, and now it's stored in that rubber band. When she releases the rubber band, it's going to go flying. So this is potential energy. Oh, here's some water up high behind a dam. Potential or kinetic? Yes, this is potential energy. This water, because it's up so much higher on one side than the other, has the potential to fall over the opposite side when they open those floodgates. Once they do, when the water starts falling, then it will be kinetic because it'll be in motion. Now, again, it's both, but listen to my description. This rocket is zooming through the air. Yes, kinetic. If it's zooming, that means it's moving, so it's kinetic. But obviously, it's not on the ground. It's up higher, so it's still potential, but you knew that when I said zooming, we were talking about motion, so it's kinetic. Look at this car driving down the street. Potential or kinetic? Yes, it's kinetic. It's moving. Here's a kid poised at the top of the playground structure. He hasn't jumped off yet. Is this potential or kinetic? Yes, it's potential. Is it because of his position or his condition? Well, actually both. It's his position because he's up high, but also the food he ate, he has energy stored in him from that, so he could just turn around and go another way if he wanted to. Do this one for Narnia. Yes, this one's definitely potential. She stretched the string on the bow beyond its normal position. That loaded energy into it. Now, when she releases the string, it and the arrow with it are going to go flying. What about this piece of coal? Potential or kinetic? Yes, this is potential energy. This coal's not moving around, is it? Nah. Now, is it potential energy because of its position, being up high or stretched or squeezed, or its condition, its atoms? Yes, condition, its atoms. The way those atoms are joined together, you catch this coal on fire, you can use that energy. Look at this water rushing over the waterfall. Again, this is both, but I said it was rushing over the waterfall. Yes, it's kinetic because it's in motion. Oh, look at Katniss running through the woods. She's running. Yes, kinetic. Yes, she's in motion. Now, here's our last one. So there's a kid and he jumps off the diving board. When the boy jumps off the diving board, does his potential energy change to kinetic energy? Does his kinetic energy change to potential energy, or is there no change in energy? Which one is it? He stands on the diving board and then he jumps off. Is that potential to kinetic? Kinetic changing to potential, or is there no change? The correct answer is A. Yes, when he's standing on the diving board, that's potential. He's up high. And then when he jumps in, now he uses that energy to fall into the water. That's kinetic. He's moving. Oh, sorry, that wasn't the last one. My bad. Okay, here's another roller coaster question. At which point is potential energy the greatest? A, B, C, or D? Yes, I hope you chose A. This is exactly like the question we had earlier. At the top of the highest hill is the most energy stored. It takes more work to get the cars to this spot than it does to this spot. Here's another one. Where is potential energy the least? Where is the least amount of stored energy? You should have chosen B. B is the lowest spot. So there's less, if you fell from this spot versus all the other spots, you come down with less energy because it takes less work to get to this spot. Now let's try this one. At which point is kinetic energy the greatest? Where would you have the most motion? Yeah, the answer is B. At the bottom, right before we hit the bottom of that tallest hill, we had the most motion because at this spot here, we've received all this stored energy, and we'd really be moving here. Remember that. Change it to the pointer here. Remember that as we come down this hill, this energy we're now using, the remainder of it will be used up as we go up to the second one. And so this one won't have as much kinetic energy because it's only receiving energy from this hill. Now we're done. Okay. Stop the video and let Miss Ewing know that you're done.